We're going now.
All right, welcome everybody to this session. We're pleased to welcome Cary Millsap today to talk about Method R. With that, I'm going to turn it right over to Cary. Please take it away.
All right. Thank you very much. Hi folks. I'm Cary Millsap. My contact information is shown here on the slide. Feel free to mail me or tweet me anytime you like. Cary Millsap at methodr.com. Don't forget the hyphen. Or you can tweet me at Cary Millsap. First thing I want to do is the first thing I want to do is get my keys working here because I can't seem to change pages. Let me, there we go. First thing I want to do is thank our host today. I know a lot of people that are attending are from Pythian itself because this is a normally Pythian internal meeting, but Pythian have graciously agreed to let this be a public broadcast, so we've advertised it at our website, and thank you, Pythian, for letting us host this event here and for allowing people outside of Pythian to attend. Those of you who are not familiar with Pythian, Pythian.com, I strongly suggest that you go take a look at them. They're awesome folks. I represent a company called Method R Corporation. This is our homepage, and hopefully it says it all. I mean, we are an Oracle performance company. We've got some good stuff I'm going to talk about today. But our whole thing is knowing exactly what your Oracle applications are doing with your time. So we have tools, we have consulting services, and we have education courses that are all directed towards that goal. If you click on this spot on our homepage, down on the problem prevention part of the wheel, you get to see one of your fearless leaders at Pythian, Alex Gorbachev, who graciously agreed to let me use his image here on this page and a quote from him. So thank you very much, Alex, for letting us do that. Our contact information that I put on the front page is valid. Here are a few other ways that you can get a hold of us. We are methodr.com with a hyphen between the D and the R. We are on Twitter at methodr with no hyphen. Facebook, you can reach us through our methodr.com homepage. And anything that you would like to know about our products, if you email support@methodr.com, you actually will automatically log a ticket in our ticket tracking system. So it's a great way to contact us about anything you want, and it gets your question in our system. So today's topic is about the Method R profiling ecosystem, and the basis, the reason that we care and even have such a thing is because of performance. So the first thing I want to do today is just kind of set up the cards to make sure that when I say the word performance, everybody thinks the same thing when I say it. So the first thing I want to talk about is what is performance, and it's really simple. It's this. You don't want to see this for any more seconds in the day than is absolutely necessary. And when a bunch of people see that, you end up with a problem. So performance is all about the user experience. And the user experience really comes in there are two ways we can measure it. The one that we focus on the most is called response time. And response time is simply the distance from when somebody asks for something from a machine until when they get the answer back. So response time is literally the distance between these two time values. If these vertical lines represent timelines that flow downward in time, then when Sanjay asks for something, the duration between when he asks for it and when he receives his answer is response time. And as you can see from the picture, everybody has different response times for different things, and people even have different response times for the same thing. Sanjay and Eric are both running a red thing, but Sanjay's red thing completed a little more quickly than Eric's red. Now, the other way that people like to measure performance is with a metric called throughput. And throughput is simply the number of request completions per time period. So on the same picture that I showed a moment ago, you can see that the only thing that's changing when I flip between screens is triangles on the end versus diamonds on the other end. So this is a picture of the same experiences that people have been having. But if we want to count throughput, what we have to do is select an interval in which we're interested. And only the business experiences that end within that interval count in the throughput calculation. So you can see that I've grayed out all the things that end outside of the T interval. And then if I want to count the throughput, for example, for the green task, the green business task, then I just simply count the number of times a green task completed within my interval. And here we could see 1, 2, 3, 4, 5, 6, 7 completions per T. So this is a picture of response time and a picture of throughput on essentially a sequence diagram representing a lot of different people experiencing the system in different ways. So how do you measure these things? Well, we've already established that performance is all about the user experience, and the user experience is measured 2 ways, response time and throughput. The problem in Oracle is that you can't see response time and throughput in OEM or ASH or AWR or ADDM or any of the other standard tools that lots and lots of vendors sell around the Oracle product. There are things like the real user experience part of OEM, but it really doesn't exactly match to the experiences at the level that I'm talking about. I'm talking about literally Sanjay clicks and 15 seconds later gets his answer back. I want to see detailed data about exactly what happened when that experience occurred. And OEM, ASH, AWR, ADDM, they don't allow you to accomplish that. So the nice thing, though, is that Oracle does give us the capability to see exactly where that time goes, and Oracle gives us this capability through these things called Oracle Extended SQL Trace Files. So that's great, but the problem with trace files is that they look like this. And nobody wants to have to blind themselves to go into a file and try to figure out what all this stuff means. So that's why there's a tool that Oracle ships with the kernel, and they have ever since the late 1980s, called TK-Prof. But the problem with TK-Prof is that it looks like this. And it's a big, long report. And as you can see on the right, there's often a lot of repetition in these reports. So that's one bit of a problem. But the real problem, I don't know what's going on with my keyboard, so let me click. The real problem with TK-Prof is actually several, and I'll show you a few. I've got some numbers here highlighted in red, and this is an excerpt from a TK-Prof report. Many of you have probably seen one of these. Maybe a lot of you have seen one today. But take a look at the elapsed duration that this thing, and this thing here happens to be one SQL statement with the execution plan shown in the middle of the page. But what we can see at billiard ball number 1 is that the elapsed duration of this thing was 0.31 something. And of course, you know that that 0.31 is in seconds. So about 1/3 of a second consumed doing this, executing the SQL statement. Now, if you look at bowling ball or billiard ball number 2, the report says that elapsed times, and of course up here at billiard ball number 1, it says elapsed right at the top of the column header. You can't see my pointer, can you guys? Okay. At the top of billiard ball number 1's column, it says elapsed, so 0.31 is an elapsed figure. So now if you look down at billiard ball number 2, it says that elapsed times include waiting on the following events. But if you notice the red number down at the bottom right at billiard ball labeled 3, the total wait time for this particular event called SQLnet message from client was 7.90 seconds. Well, how in the heck can 0.31 seconds contain or include the 7.9 seconds? And of course, there's a rational answer. And of course, it requires that you know a little bit about the fact that the SQLnet message from client event is a little different from an event like the direct path read that's right above it. But it gets tiresome to have so much of the code path for understanding a report like this to have to reside in your own brain. It really slows things down. The next thing I want you to look at is that billiard ball number 4. Check out all these times in red in the execution plan. There are a couple of things wrong here. First off, these times aren't in seconds, they're in microseconds. That's what the US stands for. So 84719 is really 0.084719 seconds. That's the first problem. The second problem is that 84719, the top red number in the view DBA source, row source operation row, that includes the time of the union all down below it, the 79997 microsecond number. So really, to see what the DBA source, the view DBA source row cost us, we have to subtract the 79997 from the 84719. And of course, everybody on this call can do that. I mean, I know you know how to subtract, and I know that you know that the next thing I'm going to say is that the filter has to be subtracted from the union all in order to see what the union all costs. Then it gets a little trickier because in order to figure out what the filter costs, you have to subtract both the hash join on the 4th line and also the nested loops, which is the first row that has a 0 in the row count. And it starts to get tricky at that point because it's just a lot of work, and it's extraordinarily tedious to go out and try to figure out what the individual costs of these lines are. But you have to in order to know which of these execution plan lines to really begin with. Because I hate to surprise you if you don't know this already, but the row count column on the left is not a reliable way to attack an execution plan. The final thing I'll mention is at the very bottom, it says that there are 8 elapsed seconds in this trace file. Now, first off, that's not a very precise number. We go from thinking about microseconds to now getting an integer number of seconds, which to me is a little bit bizarre. But secondly, where'd the 8 come from? Is the 8 the 7.9 added to the 0.31, or is it the 7.9 rounded, or what is it? So this is a very quick tour of what happened back in about 1998 or 1999, shortly right around the time that I left Oracle, that I started getting the idea that this can be done so much better. The big problem with TK-Prof is it's not a profile. And a summary of some other things that I think are really important to understand is that TK-Prof ignores skew. If you see me talk about skew, you understand what that means. It ignores bind values. It ignores parent-child call relationships. It ignores the P1, P2, P3 value in the OS calls. It ignores durations between SQL statements because TK-Prof only reports on the little islands that are SQL statements. It also ignores the unaccounted for time within database calls, and it ignores individual row source operation timings, which is what I showed you just a second ago. So in short, TK-Prof just does not harvest enough value out of a trace file, and what it does harvest, it renders in a somewhat awkward format, which is really a problem if you've got this just outside your door. So that's the motive for why we have something different. And the thing that's different that we have is what I call the Method R profiling ecosystem, and it consists mainly of 3 tools, all built by our company, Method R Corporation. So the first tool is a tool for collecting perfect trace data with really no extra effort, and it's a tool called Method R Trace. We call it Mr. Trace for short. The second tool creates a perfect profile out of that trace data, and that profiler is, of course, called the Method R Profiler. The third tool is the one that does all the dirty work, and I'll show you what the dirty work entails as we go through the case study here shortly, but it's called Mr. Tools, and it's actually a suite of command line and graphical user interface driven tools that I'll show you extensively throughout the next 45 minutes. So the workflow of Mr. Tools is this subway diagram. Forgive me if this looks kind of strange, but I thought last night it was a great idea to draw a picture that looks like this. So I'll talk first about the green line. The green line is what I normally do. I'll run Mr. Trace first, and then I'll run the profiler. And then if I need to drill into something, or if I need to fix the trace file in some way, and I'll go through an example of fixing a trace file, then I take the green line loop from Mr. Tools back to the profiler, which I might run 3 or 4 times. So I might run Mr. Trace to grab the trace data, the profiler to see the results of the story that the trace data tells me, and then Mr. Tools to refine my queries into the data, and then maybe the profiler again, and maybe Mr. Tools again. So the green line is kind of the main thing that I do because I own all 3 tools. And those of you who at Pythian who opt to, there's a plan in place that allows you to do this as well. The gray line on the bottom is kind of the express train from Mr. Trace to Mr. Tools that people that take the Mastering Oracle Trace Data course use. Because in the Mastering Oracle Trace Data course, we really don't talk much about the profiler, and that's because Mr. Trace and Mr. Tools come with the course, but the profiler doesn't. We've tried to keep the price of the course down low enough so that more people can attend, that some people opt not to purchase the profiler. When they do, though, they find that Mr. Tools actually has profiling capability built into it as well. Mr. Tools really focuses on flexibility and versatility, though, whereas the profiler focuses on the simplicity, structure, and guidance that makes it a really easy tool to run. So if you have both, I like the green line, but if you don't, the gray line actually gives you perfect trace data and then allows you to go and execute queries against it using Mr. Tools in a loop so that you can get to the root cause of your problem, even if you don't have the profiler. Now, the blue line is something that a lot of people do, including me. Sometimes the trace file that we get comes from someplace other than Mr. Trace. And sometimes all we do is we run the profiler one time and we solve the problem. And that's a pretty common track, this blue line. Of course, at the Mr. Profiler station, you can get off the blue line and onto the green line and loop through Mr. Tools and the Profiler if you want to. The other fairly common track is this orange track that a trace file comes from somebody else. You run Mr. Tools on it one time, or you can hop on the green track or the gray track and run Mr. Tools, the Profiler, or maybe Mr. Tools in an iterative loop. So this little subway tube map, I think, is a fairly reasonable way to explain some of the workflows through the three tools. So enough theory. Let's get right to the case study. What I want to do is show you today a case in which a user had a 32-second user experience, and they brought the trace file to us. Now, the question is, can we improve the response time? I stated this in a fairly neutral way. A lot of times users come to us with trace data and they tell us we have to improve the response time. But sometimes, for example, as is the case in a performance assessment engagement, people just simply want to know, are we doing as well as we could be? And a lot of times we go in, of course, there are plenty of dashboards running on the DBA's desktop. There are lots of green lights saying, yeah, the system is all efficient and all running as fast as possible. And in the particular case study that we're going to talk about today, it's very likely that all the lights on the dashboard are green, because the problem that we're going to find, I'll give you a little foreshadow here, the problem that we're going to find is not a problem that typical DBA dashboards can help you even understand exists. So I think it's kind of a cool demo. And from here, I'm going to actually close down Keynote for a couple minutes, and we're going to go to the method R profile. So let me go here, and I'm going to go ahead and minimize that so it won't be a distraction for us. And I've got a couple of windows open here. I'm going to clean my desktop off a little bit. A couple of windows here. One is the method R profiler itself, and that's the window here that I've made a little bit bigger. I know that my resolution is so huge. I'm going to pause for a second and just ask if you guys can see this. If you can't, I can change the resolution on my big display monitor. So let me ask you guys for some feedback at this point. Is this too small to read?
It's pretty small, Cary. If we can go a little bigger.
Yeah, that's what I thought. Let me go kind of off script here to my system preferences and see what we can do about it. And if my friend weren't sitting here next to me in my office with the webcast up, yeah, I see people begging me, yeah, to please make it bigger. So let me go to my displays here, and I'll just kind of drop the resolution of my screen down. So let's go from nearly 3,000 down to 1024 by 768 ought to accommodate most of you. This may be a little bit radical the other direction, but is that much better?
That's lovely.
Okay, very good. So I'll explain my desktop a little bit while I kind of resize some stuff here. I've got a Finder window in the background that has my my whole story in it. So you can see I've got steps 1, 2, 3, and 4 that we're going to go through. So I've got a whole directory full of stuff here, and the slow.trc is the trace file that somebody handed me. And I know this isn't going to do a whole lot of good to see, but I just want you guys to see what this stuff looks like. And there are thousands, there are actually 250,000 lines of trace data inside this file. You can see the 225,000 figure at the bottom here. So nobody's going to want to have to look at this thing with their bare eyes. Now on the right here, let me go ahead and resize this a little bit so I can kind of see more stuff. This is what the method R profiler graphical user interface looks like. And what I did previously was I took the slow.trc file and I dragged it right from the Finder into the profiler, and you can see now there's a progress bar that shows that slow.trc is running, and it's, I don't know, it'll take a few more seconds to run. It's a 25 megabyte file, so you can kind of understand that there's a lot going on here. But in a few seconds, this thing will be done, and it'll create a profile report that will transfer the row down to the bottom panel of this page here. And actually, while it's running, I'm going to go ahead and turn on this automatically display the HTML in a browser thing. I could cheat and go show you the one that I've already prepared, but this thing's almost done. I'll take a sip of water real quick. All right. So the browser pops up because I depressed this button here. That's the automatically display when you're ready button. I usually leave that off during a demo just to make sure I don't have any unexpected surprises. I'm going to come back up here, and I'll go ahead and change the aspect of the screen here. So what we're looking at now is the output of the METHODR profiler. And what you can see is that this file accounted for 86.176 seconds. Hopefully that's the first thing you see because it's red and it's bold. And the profiler goes on to explain where that time went. So here's where the 86.176 seconds went relative to database calls. Here's where the 86.176 seconds went relative to SQL statements. And here is where the 86.176 seconds went relative to cursors, which are associated with SQL statements, but cursors have parent-child relationships among the SQL statements. So great, we have an explanation for where 87.176 seconds of our time went. The only problem is, and I'm going to go back to Keynote for a second, if I can find it here. The only problem is the user had a 32-second experience. So that's no good. We've got a report that explains where 86 seconds or 87 some seconds of our 32-second experience went. So what are we going to do about that? 86, and again, I know you guys are smart enough to remember one thing here, but 86 is what our report says, but 32 is what our user said. So the first thing we have to do is figure out where the extra 54 seconds came from. It's obviously not the right profile to be looking at this 86-second long thing. So let's look at it a little bit more carefully. And what you can see in the report is that 54.415 seconds were consumed doing this thing called SQLnet message from client, which has the label that I've highlighted in brackets that says think time. And the call count is 2, and the total response time contribution was 54 seconds, which ends up being 63.1% of the total time. Now, most of you who've never seen the profiler before probably have no idea what this think time thing is, but you can probably guess from the name. Well, this think time thing in brackets is something that the profiler actually makes up. And to show you what it means, I'm going to go all the way to the end of the report. At the very bottom, there's a section 5.3 called Call Definitions. And what you can see on row 1 here is that there is a SQLnet message from client configuration option in the profiler in this file called blah, 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 cdefs.xml that says when the elapsed duration is greater than or equal to 1 second per call, then what we want to do is label that as think time and put it in a separate bucket from all the other SQLnet message from client. So because of this configuration option here in the profiler, which is standard, it's a default option, this thing that I've got green highlighted, we get an extra row called think time that all SQLnet message from client calls that last longer than 1 second apiece go into. And because we only have 2 calls here that are longer than 1 second apiece, we can see exactly how long each one of them is. The smaller one of the 2 was 26.2 seconds, and the larger one of the 2 was 28.1 seconds. So the reason we do it this way is because there's some SQLnet message from client that you want to pay attention to in your analysis, and there's some that you probably don't. And in the profile here, we're seeing that 54 seconds or 63.1% of our time is time that we really don't want to be looking at because the way that this trace file was collected, I'm going to dip over to Keynote and show you a picture here real quick. Let me go ahead and put this up on display. This is how the data was collected as it turns out. A user decided to turn tracing on and then run his select statement. But the problem is that between turning trace on, which enabled tracing immediately within the database tier, the user went off and did some other stuff. And in this case, this bubble number 3 here, which is explained in a paper I'll give you the URL to shortly, this user went off and did some email. And then when he came back and remembered, oh yeah, I'm supposed to type in a select statement and trace that. Well, he typed the select statement here in this time sequence number 4, and then he went ahead and hit the enter key, semicolon enter or slash enter, and the database got to work fulfilling the select statement. On bubble number 5, the user went back to doing email. Actually, bubble number 6 is the user doing email. Well, the green shaded area here on the left, labeled experience, is the time that this query took from start to end. But the user continued doing email until down here at billiard ball number 7, where he realized, oh, my query's done, I better turn tracing on. So he typed a turn tracing off command, and at time ball 8, executed the tracing off command. So as a result, the trace file on the right, which is in red, is much bigger than the experience, which is labeled in green here on the left. So we have a mismatch between the trace file's representation of the experience and the experience itself. So the problem with that is exactly what shows up here in the profile has way more time in the bottom line than what we really want to see. Now we have two ways we can progress here. We could just sort of mentally ignore the 54 seconds, and then we could move on and say, okay, well, I know this 22 and all these other things really are my experience, but the first thing we'd have to do is subtract the 54 from the 86 and figure out, is that really 32? And it ends up that it is, but I don't like carrying subtraction in my head. For example, what percentage is 22 seconds of 32 seconds? Well, I don't want to have to calculate that in order to find out. I'd rather my report show me the 32 seconds at the bottom line. So what do we do about that? Well, one of the things that we could do about it, and I'm going to go back here to the raw trace data, and I'll go ahead and open it up again and show you something. We can actually, by inspection, because this file is not really all that big at the very beginning, we can actually see something interesting here. On line 27, we see a wait that says SQLnet message from client with an elapsed duration of 26,294,757 microseconds. Well, we know because there's a decimal point that goes here, but that's 26.294,757 seconds. And if I go back to our profile, you can actually see, I thought I went back to my profile. There it is. If we go back to that profile, you can actually see that 26.294,757. It's the same number as you see here, 26.294,757. So the profiler has picked up this line 27 as think time, and there's another line inside the trace file too, and usually we can guess it's going to be at the bottom. And it's not exactly at the bottom because there's a bunch of stuff between us and it, but if I scroll, and here I'm going to have to scroll a decent bit of real estate, but somewhere in here, we're going to find a wait that says SQLnet message from client that will show us the other 28 seconds. Now, it's not easy. In fact, this trace file is probably easier than most. I could do tricks like go to the bottom and seek for question mark, SQL. Sorry, I'm having some fumble fingers here. So I could look for it that way, and sure enough, on line 225,320, I found the other 28-second SQLnet message from client problem. So there's quite a bit of real estate between the bottom of the trace file and that, but I can find it in VI if I'm just moderately clever. Well, I don't want either of those two lines, and I shouldn't have closed the trace file. I don't want either of those two lines in this trace data. So what I could do is just comment out line 27, which will cause the profiler to think that line 27 is not trace data after all. And I could go to that line 225,347 or whatever it was, and I could comment it out as well, or I could just delete the lines. So I've actually already done that. I'm going to undo this change and quit this file. I've actually already done that in this other directory where I've got my slow trace file, which I have actually edited. And on line 27, you can see I commented that line out, and if I go down to the bottom of the file, trust me, I've commented the other line out as well. So that ought to fix our problem, right? We ought to have now a file that contains only the information that we need. And let me show you what happens now when I profile that slow vi.trc. It'll take about the same amount of time as the other one did, which the next time I do this, by the way, I'll do it a little earlier so we don't have to wait. I'll hide the latency a little better. Excuse me, I've got to get a little drink of water there. So when this runs, I'll go ahead and open the HTML file automatically as well. And it's almost done. Let me go back over here. I'm going to clean up a little bit because I've got two windows with the same stuff in it on this browser page. So think about what you should expect to see when this profile opens up. What we're hoping for is a 32-second profile that doesn't have any SQLnet message from clients in it at all. And ta-da, our soup is ready. So let's go see what's going on. Well, that's weird, isn't it? We get the same 86.176 seconds. That's not at all what we want. I wonder if I get the right file. Well, wait a minute. The profile looks totally different. It's still got the 86.176 at the bottom, But now instead of SQLnet message from client sync time for 50 some odd seconds, we've got this weird row at the top, unaccounted for between database calls, 34.411 seconds, and we've got a max of, that's a familiar number, that's a weird SQLnet message from client that we've got. And here on the CPU service unreported calls line, that's new. We've got one call that lasted 26.524953. That's weird. So the reason this doesn't say 32 is because we've got these two new rows at the top, and what in the heck are they? Well, this is what happens when you hand edit a trace file. What the profiler is doing is every line, it looks to see what the time on that line is. And if the clock moves, it hopes to find, and when I say it, I mean the profiler, it hopes to find an explanation for why the clock moves. Well, what we've done with our surgical axe is we've gone into the trace file and we've eliminated the description of why the clock moved from one value to the next. So the profiler is trying its best to figure out how to explain the clock jumps that it saw. And it's kind of weird and it's very subtle and complicated to explain why these two lines are what they are. The much easier explanation is to tell you that we shouldn't be seeing them because we've given the profiler really a faulty input trace file. So it's doing its best to make sense out of what we gave it, but what we gave it doesn't make sense. So that's what happens when you try to edit a trace file by hand and run the profiler on it. So that leaves us then with the problem of, well, what are we supposed to do? Well, we encountered this problem enough that we created a tool to help us solve it. And earlier when I talked about Mr. Tools being the set of tools that help us do our dirty work, well, here's some of the dirty work I was talking about. Now I'm going to cut into using the Mr. Tools GUI for a moment. I'm going to get to that in a second. Here's what the MethodR Tools GUI logo looks like. But the job at hand is we want to cut out two lines of our trace file, but we don't want to leave the profiler wondering what happened during the execution of those two things that caused the clock to jump. So I think the best way for me to show you what's going on here is to go to a terminal window. And I'm in the directory. I'm actually not. Well, I'm close enough. What I want to do is show you the man page for a tool called Mr. Call RM. Mr. Call RM is the call removal tool that's part of the MethodR tool suite. So the MR stands for MethodR, and Call RM is probably self-evident. So if I go ahead and man the Mr. Call RM tool, you can see that its description is it removes calls from a trace file. It takes a set of options and a file name, and the options include this one here. I can list the line numbers of the calls that I want to eliminate. So the Mr. Call RM that I want to execute is going to say Mr. Call RM slow.trc, and my options are going to say minus lines equals a list of lines. And the list of lines can look in any number of ways. You can use dots or dashes to represent ranges. This minus lines option here would say get rid of everything up through 5, also 8, also 10 through 12, and also 1,000 and onward. So it's a very flexible command line syntax. But what I want to do is delete two specific lines. Now, which two specific lines is a question that I need to answer before I move on. Now, a while ago, you saw me get into GVim, to VI, and figure out that I needed lines 27 and line 225,300 some odd to get rid of. But I hate having to use VI to figure that out, because what if there are other calls in the middle of the file that I don't want either? Well, we have a tool for that too, and that's what the Mr. Tools GUI gives us a quick and easy access to. Let me go ahead and move this over here where we can see it. So what I've done is I've preloaded our slow.trc file into the top panel, and this works a lot like our profiler. All you have to do is just drag from the Finder into this window, or you can click on this Add button, and you get a Finder that you go search for whatever you want to add to the panel. Since I've already added this one, we're all good. Now the report that I want to run, and I just right-click to get this list, or I could have clicked on this button to get the same list. The report I want to run is possible. Well, let's just take a look real quick. I'm gonna only highlight a few of these because we have a limited amount of time today. But I could run a response time by subroutine call name, which is roughly equivalent to the top profile in the profiler report. I could run the response time by subroutine call name with think time removed. Now that sounds encouraging because that would give us an approximate top profile and a profile report without the think time in it. And in fact, if I click there, you can see it asks me, what do you consider think time to be? And I can say, well, anything in excess of 10 seconds is definitely think time. And if I ran this, we'd wait 10 or 15 seconds for the report to come. But I really don't want this report either. The report that I want is this thing called response time histogram for a given call name pattern. And let me run this real quick. And it'll ask me which call name pattern I want. And SQL message from client is luckily the default. So I'll go ahead and click that. This will take 10 seconds or so to run because, again, the file's 25 megabytes in size. So while this runs, I'm going to explain to you what we expect to see as a result. In fact, I don't have to. Here we go. What this shows is a histogram that indicates that there were 74,756 SQLnet message from client calls that lasted between 100 milliseconds and 100 microseconds and 1 millisecond. So that accounts for 26% of our time. But if we look at the percentage column, the big load is down here in the 71% bucket. This says that 2 calls each took between 10 and 100 seconds apiece. Now, the reason I ran this report is I wanted to know that there were only 2. Now, we knew that before from the profiler, but this report shows us that there weren't any calls between 1 and 10 seconds. There were 2 calls that were between 10 and 100 seconds apiece. Now, the next thing I want to do is with that same file, I want to find what line numbers were those things on. And I can run that report by clicking here on this response time by line number for a given call name pattern. And again, luckily, SQLnet message from client, which is what I want, happens to be the default. So I'll go ahead and run that report. And what we're going to see is a Mr. Skew command. And by the way, you can do this at the command line if you want to, but I find it's a lot easier to just point and click. What this is going to do is group all the SQLnet message from client calls by line number, and it's going to label that line number column with the string LINE. So the reason I show you this is because this is all modifiable. If I wanted to do stuff, I could just type it in here. And I could say, for example, where dollar accounted for is greater than 2 if I wanted to. And that would only show me calls that have accounted for durations larger than 2. Well, I don't really need to do that right now because I've gotten exactly what I need. And what I need is to know what line numbers are the largest calls on. And the first largest call, the 28-second one, is on line 225,320. The second call, the second largest call, is 26 seconds, and it's on line 27. The third largest call is only 95 milliseconds, so we're done here. These 2 calls right here and here are the only ones we really want to go get rid of with Mr. Call RM. So now what I can do is I can go back to my terminal window. We don't have Mr. Call RM wired into the GUI yet. So, whoops, I need to grab the corner and then pull it up here. So what I'm going to do is I'm going to quit the man page, and I'm going to make sure that I'm in the right directory. So my directory structure is 1 is my slow stuff, and 2 is my slow VI edited file. So I'm going to change directory into 3.blah. And in there, you can see that I've actually already run Mr. Call RM on the TRC file. Here's what I would have done to do it. I would have said Mr. Call RM /1, so that other directory, slow.trc, -- lines equals 27, 225320. And I could have listed those in either order. Now, if I do that, I'm just going to pipe the output to more, and I want to show you what it looks like. So here what we see is the exact same trace file that we had before, except when we get to, and you know what, I'm going to do a little fancier thing here. Instead of piping to more, I'm going to pipe to NL minus, I think it's B, to show me all the blank lines too. I think I have to say B capital A. I may not have remembered that right. Man, NL, sorry about this. I just want to show all the line numbers. Oh, it's minus B lowercase a. So I go back up and I'll do the exact same NL command, except I'll shift the A back down. And now what we can see is the line numbers as they're being edited. And on line 27, notice what happens. On line 27, the elapsed value used to be 26,000 or 26,294,757, but now it's a 0. Well, Mr. Call RM has actually changed that to a 0 for us. Now, let me show you something else that's kind of cool. If I go back to our original trace file, slow.trc, I open it in VI. Let me go ahead and make this window a little smaller so I can see that and this at the same time. The original line 27 said 26 million blah, 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 whereas the new line 27 says 0. Look at the TIM value here, and look at the TIM value here. They're different. And the reason they're different is because Mr. Caller M has subtracted 26,294,757 microseconds from this TIM value there to result in this TIM value. So not only has Mr. Caller M made the elapsed duration 0, it has sucked the clock back. It's basically sucked the response time out of the file by adjusting the clock on line 27 and 28 and 29 all the way through the end of this 250,000 line trace file. It's pulled that time out so it looks like it never happened. And it does the exact same thing if I go all the way to the end of this file, and I probably am not going to, well, I'm definitely not going to bore you with that. So let me go ahead and Control C this. But if I go to the end of the file, you'll notice that the ELA value on that wait line is 0 as well, because I've said to make that line go away with Mr. Caller M. So it's a really simple to use, but just devastatingly powerful tool that enables us to change the trace file so that now we can go and run the profiler upon it. And so now let's go ahead and do that. I'm going to pull the profiler open, and whoops, I didn't mean to do that. I meant to take the slow Mr. Caller M. So what I've done is I've run Mr. Caller M on the original slow.trc. I pipe it to the file called slow-mrcallerm.trc, and I'm going to drag it into the profiler, and it's going to take about 10 seconds to run. And we'll see if we don't get the 32-second response time experience that we were hoping for. While this runs, I want to make sure, I don't know if anybody's out there trying to take notes while I'm doing this, but everything that I'm describing is documented in glorious detail. I've detailed it very carefully, and it's available to you on our website. So there's a paper that you can download for free. Those of you at Pythian probably already know what it is, because I think that the folks who set up this particular event have already sent it to you. But all this stuff is listed in this paper that will allow you to go reproduce the problem, including the SQL that we're diagnosing. So now, finally, we see the perfect profile for our end user experience. The user experienced a 32-second response time, and we are showing a 32-second response time now in our profile. And now in our profile, we can see that SQLnet message from client is 69.8% of our time, but it's not big SQLnet message from client calls. It's SQLnet message from client calls that are very small, but there's just a lot of them. Now, a lot of people who are classically trained DBAs would look at this and say, well, this is rubbish. That top line shouldn't be in this report. But imagine what this report would look like if the top line weren't there. You can tell what it would look like. It would consist of about 9 seconds of response time. The problem with a report like that, and by the way, that's what TK Prof is going to try to lead you to believe. A problem with a report like that is that you can't diagnose a 32-second problem if you're only looking at 9 seconds of the data. We need to see where all 32 went. So the people that think we should throw out line 1, you've got to ask them, well, what should we do? Should we go to the end user and tell them, you know, I know you're waiting 32 seconds, but good news, 22 of that 32 seconds you shouldn't worry about because it's idle time. Well, that's preposterous. The user has to wait for these 22 seconds just as much as they have to wait for these 6. In fact, these 22 feel 3 times worse than these 6. So we really need to figure out what's going on here with the 22 seconds of response time consumption in the SQLnet message from client bucket. Now, the key here is in bright red, and that's the cool thing about the profiler. Mr. Tools requires that you know what to ask for. The profiler knows what you need. So the profiler shows you the things that you need to be focusing on in bright red, bold letters. So here we can see that there's a problem, something about the 75,002 calls that's a problem. Now in the profiler, I can go see things like which SQL caused all these SQLnet message from client calls. I can also scroll down and see the SQL that caused them all because there's one statement that accounts for 99.2% of our total response time. And if I click on the drill down link over here at the right, I'll actually go get to see the statement. The statement's incredibly simple. It's select star from video 1. And if I wanted to see the statement text, I could click here, or I could just scroll down a little bit. And there's the whole statement text right there. Select star from video 1. It's a very simple case study. I wanted you to be able to replicate it if you wanted to. What the profiler is showing us is that it took 31.505 seconds, which is 99.2% of our task's total time. We can see that this cursor had no parent, so it's not part of a PL SQL block or part of a trigger, for example. And we can see that this statement, 31 seconds, is 70.4% consumed by SQLnet message from client. And that SQLnet message from client is itself 69.8% of the total response time. And here, if you remember the call count a minute ago, is all but one of the SQLnet message from client calls. So if we look down in the next section, which is called Profile by Database Calls, it tells us what's going on. Here's where TK-prof wouldn't. TK-prof would have shown us parse, exec, and fetch in that order, and we would have seen only about 3 seconds of the 31 seconds of response time. What we see here is that 90.7% of this statement's time is spent between database calls. In other words, not doing SQL processing, but doing stuff in between SQL processings. And we can see the problem here. There's 75,000 fetch calls that are returning 150,000 rows. So we can kind of smell here that we're only returning 2 rows per fetch call, or at least we're returning an average of 2 rows per fetch call. We don't know for sure how many rows we're returning for each fetch call because there's no further breakdown in the profiler's output of how many fetch calls are being returned by each, or how many rows are being returned by each fetch call. So let's go back to Mr. Tools real quick, and I'll show you another report. This is the slow.trc file, and we don't want that one. We want this other one, which I think, let me not do it this way. I can find it faster if I go back to my Finder window. So let me go here. I'm going to go back to the slow mrcallrm.trc file. I'm going to drag that into my Mr. Tools window. So now I've got 2 files in my window, and I want to select only the adjusted one. And here's the report I'm going to run for this one. I want to see the number of rows returned per database call. So I simply click on that. And in a few seconds, by the way, I've got Harold Palacio sitting in my office next to me. Harold's the guy responsible for the design and implementation of the GUI. So he's sitting here with his, with his brace position in case something, doesn't work. But there's not going to be anything that doesn't work, so he's going to be cool. So here you can see that the report returned a call name column, a rows column, a number of calls, a mean, min, and a max. And what we're seeing here is that fetch calls returned 150,000 rows, which is completely consistent with what the profiler showed us. And we can see that there were 75,001 fetch calls, which is also consistent with what the profiler showed us. The 75,001 is right here in red, right there. So what we can also see is that the average number of calls rows per fetch was 2. But now we can see the very clear information that the minimum number of rows returned in the fetch call was 1, and the most we ever returned in a fetch call was 2. So this tells us completely unambiguously that we are doing no more than 2 rows worth of processing per fetch call. Now, those of you who know what an array fetch in Oracle is are probably laughing, thinking, what kind of developer wrote that? And it happens all the time. The default array fetch size is normally what gets picked up when somebody writes code because the person writing the code doesn't really realize they have control over such a thing. So what we can do now is we can kind of come back to the trace file or to the profile and say, I wonder what would happen if we return, say, 20 rows at a time instead of just 2 rows at a time. Well, if we return 20 rows per fetch instead of 2 rows per fetch, I would expect this call count to go from 75,000 down to 7,500 because we're basically eliminating 90% of the calls. We're cutting the call count by a factor of 10 by returning 10 times more rows per fetch call. So if we do that, I would expect that we would process the same number of rows with 7,500 fetch calls. And the important thing about that is notice how this call count here, the fetch call count, matches the SQLnet message from client call count. And it makes perfect sense because every fetch has to do a network round trip back to the database server. So the client, in order to get the call from the client to the server, has to send it through the network. And this line up here in the profile by subroutine that I've got painted green right now, this is how much that costs. So if I make the call count go, the fetch call count go from 75,000 down to just 7,500, I ought to be able to reduce the total response time for the network round trips from 22 seconds down to probably only about 2 seconds. So I'm going to double check here and make sure that I've got myself on track. There's one thing in the paper I just want to make sure that I've done correctly. Okay, in the paper, I've actually done the analysis on what would happen if I made the array fetch count 100 instead of just 2. And in that case, I should be able to drop this 75,000 down by a factor of 50. So if I take 75,000 and divide it by 50, I should only have 1,500 SQLnet message from client calls if I make my array fetch size equal to 100 instead of 2. So it's an interesting thing to think about. If we did that, I should be able to expect that this 22 is going to drop to about 2, and maybe I'm going to knock 20 seconds off this 31-second response time. So we can talk about that with our boss and decide, hey, it's going to take me about 20 minutes to do this. I think when I do it, it's going to knock about 20 seconds off our response time of this task, which users run, umpteen thousand times a day. Will you let me do it? The answer hopefully comes back, yes, it sounds like a good investment of a half hour. So what I want to do now is to go ahead and show you, after making that change, what the profile looks like of that particular execution. So fast.trc is actually the trace file of the execution after we make the array fetch size 100. And I drag it to it's fine, I'll need this later, but I meant to drag it to the profiler. So if I drag fast.trc into the profiler, I'll go ahead and open it automatically. You'll notice one thing about it, the trace file is much smaller, which is a good sign. And you'll notice the profiler runs a lot faster too. And now, wow, look at what we got. We got a 1.8-second response time. Wait for the screens to refresh out there. We got a 1.8-second response time. SQLnet message from client still at the top, but we're only doing it 1,500 times now instead of 75,000 times. Let me go ahead and click down. Select start from video 1 is still our most costly SQL statement, but let me go drill into the stats for this thing. It's only a 1.6-second statement now. It's still spending more time between calls than doing anything else. We're still returning 150,000 rows, but now we're only using 1,501 fetch calls to do it. Because we're only doing 1,501 fetch calls, our call count of SQLnet message from client is only 1,501. Notice something. I'm going to go back to the slow one real quick. If I go down to the statement, let me show you some stuff that was read. You notice the 75,000 was read in the profile by database call section, but in the faster one, the 1,500 call count is not read anymore. Well, the reason it's not read is because the profiler knows that if the average number of rows processed is bigger than 2, it's not going to turn the call count red. So basically, the profiler was kind of leading us by the nose. It was guiding us with color to understand that the call count was bad before. The 75,001 is bad compared to the 150,000, but now it's telling us it's okay because it's not painting it black or not painting it red anymore. Now, in case you're wondering, this is a configuration parameter too. I've just skipped to the bottom of the trace file, and I'm going to have to find it here. But somewhere in the section called Input Parameter Listing, there is there's a threshold, and here it is on line 10. It's called Fetch Array Threshold. If we don't return at least to an average of 2 or more rows per fetch call, then the fetch count is going to be painted red. So this parameter here is what caused it. And if you remember, our average looked like 2, average rows per call looked like 2, but since there was a 1 in there, it ended up being 1.99 something. So it actually failed to hit the 2 threshold, and that's why that number was red. So let me go back up to the top in case I want to refer to it again here shortly, and then I'll go back to here. So that's why this number was red on the 7,500 calls count, but it's not red on the 1,500 calls count. So again, the profiler is meant to be simple and to guide you. Mr. Tools is meant to do anything you want it to do. So if I go to get the fast trace file, which I did already, let me go ahead and run that same report. The report was the rows returned by DB call. So I can run it either by clicking here or just by clicking here to run the same report on a different file. And now you can see that there are 150,000 rows being returned. It's the same as before. I got to drag here so you can see. Window's a little small. So it's the same number of rows that I got before. The 150,000 is the same here as it is here. But now instead of 7,500 calls, I'm only using 1,500 calls. The average number of rows per fetch is 100. The minimum is still 1, this number here. And the maximum now is 100. So I'm actually getting 100 rows per call on most, and that's why my mean row count is 100. If I wanted to see some decimal points, I could say, for example, run this report again with a precision value different from 0, and you'd see it won't take very long to run. Now you can see that my mean is actually 99.9 rows per call because one of them returned 1 and a bunch of others returned 100. So you can monkey around with these things any way you want by manipulating this row that I've painted green here. So let's kind of go back to the slides and recap what we've done here. Let's see. There. I don't know why it's not popping up, so let me grab it from here. I'll maximize and I'll play. So we've used the profiler, we've used the METHODR tools, and what we've accomplished is we've taken a 31.761 second experience and we've turned it into a 1.884 second experience. And that's a savings of 94%. Guys, that's a pretty good day. Not a lot of days that I get that big of an improvement, but some days I'll get a couple more 9s in there too. And the thing that I want you to realize is that normal tools don't find this problem because normal tools throw away that SQLnet message from client. And it's not just this kind of problem that these tools are convenient for. I mean, anything that takes more time than you think it should is a good candidate for these tools. I haven't done a Mastering Oracle Trace Data class reunion in some time, but in the next one we do, which will probably be next month sometime, I'll show you another example that's a completely different thing. It's an I/O, a disk I/O problem that there's no way you would ever have found with conventional tools. You just couldn't have found it. So let me recap. It's coming up on the 1 hour mark, and I know that you guys have got other things to do today, but let me recap some of the lessons I hope you've learned from this thing. Number one, and this is the most important thing I'm going to say all day, your trace file must account for exactly the duration of the end user experience. If it doesn't, the analysis is just so much harder. And TK-Prof this is really TK-Prof's biggest problem, because TK-Prof shows you the duration of the individual SQL statements, but it doesn't show you the duration of the stuff that happens between statements, for example. It kind of does, but digging it out is just murderous. It's actually probably easier to dig it out of the trace file directly than it is to dig it out of the TK-Prof output. Second thing is if your profile matches the response time experience that you're analyzing, then problems cannot hide from you. It doesn't matter what tier they're on. They can be in some SAN someplace. They can be on the network. They can be in the application.NET code. If your profile matches the response time experience you're trying to analyze, then problems cannot hide from you. Now, you may have to go get detailed data off some other tier, but you will know for sure which tier it is. Third and final thing that I hope you remember today is if the duration dominates your user's performance experience, then you have to pay attention to it no matter what it's called. I saw a guy at a conference one time present that the wait event, the Oracle wait event called file open is not important. And ironically, about 2 weeks prior to that presentation, I had seen a profile in which file open was like 80% of the response time of something that had the insert update problem. You know, the code that if the row's there, you update it, but if the row's not there, you insert a new one. And if you do those in the wrong order, for example, if most of the rows are going to be there and require updating, then you want to do the update first. Because if you try to insert first, you'll get an ORA 000001 error, which means, sorry, but there's a duplicate key and index already. So if you do them in the wrong order, what has to happen is a bunch of extra code path. And in this particular case, the extra code path was opening the Oracle errors text file, and that was causing the response time problem that people were experiencing. And file open was exactly what showed up at the top of the profile. There is no event in Oracle that's never important. An event is important to the extent that it dominates a user's response time. So if it's at the top of your profile, it's important by definition. If it's not, then it's not important today. The tools we used, I didn't show Mr. Trace because I just showed you a trace file that somebody handed us, But if somebody had used Mr. Trace, we would never have needed to use Mr. Tools to do the Mr. ColRM thing. Mr. Trace's focus is efficiency and effortlessness. Basically, if you use Mr. Trace in SQL Developer, there are no extra clicks. Your trace files come for free. All the FTP work, all the turning trace on and off work is taken care of completely automatically, and you never have to fool with it. The MethodR Profiler is built to be simple, to give you structure, and to give you guidance. And it guides you with color, it guides you with hyperlinks. Mr. Tools is a very unguided type of tool, but its focus is flexibility and versatility. With Mr. Tools, you can do any kind of BI or ETL operation upon trace data that I've ever seen people need to do. So that's how the tools fit together. Real quickly, I'll show you some references, and I'll go ahead and stay on the line. I know, guys, that we got started about 3 minutes late, and now we're 3 minutes past the hour. But I'm happy to stay on the phone with you for a few more minutes if anybody has any questions, or if the moderators back up in Ottawa have anything off the chat that you'd like me to address, I'd be happy to do it.
Before we go into the questions, Cary, it's Alex speaking. Thank you very much for doing this session for us. Very much appreciated. I hope the folks outside of Pythian appreciate that we open up the Pythianology session as well. Just wanted to thank you personally for doing that for us.
Thank you, Alex. I appreciate the opportunity.
And yes, we can stay on the line, and you know, as soon as folks have a few questions, and we'll close it after that.
Yeah, we'd like to thank everybody for taking the time today to join us, and those that wish to hang on and ask questions, we'll do that. And everybody else, please take our thanks and have a great day. Thanks, Alex.
So I'll put a time limit on of about 20 minutes,
Yeah.
and then I need to go do my next thing. But hopefully that'll give us plenty of time if anybody has anything you'd like to bring up.
Anybody who has questions, the easiest way is probably ask them through the chat. So one question, when and where is your next mastering class? And I imagine the website is probably the right answer for that one.
It is. Let me go take a look at that, because I don't think that we have one on the schedule right now, but I may be wrong. Let me climb out of a bunch of stuff here. I can get rid of, yeah, I can blow that. So let me go see here. Let's probably just get a Windows Any. So if I go to methodr.com, the homepage is where we keep our calendar, and it's about, I don't know, 2 scrolls down. This is the event that we did today, and in fact, I don't have a Mastering Oracle Trace Data course on the calendar right now. Got a few conferences that I'm doing, but not one. What I recommend, because I need to do one of these things at least once every couple of months, and what I generally do is kind of see where the demand is and go there. The classroom that you see the picture of here is a nice size. You know, I have to have a certain number of people show up before it makes economic sense to get on an airplane and go do one of these things. But was the question from within Pythian or outside of Pythian?
It seems to be within.
Okay. And that's, I mean, it changes things a little bit, because if there's enough interest within, Alex and I had already been talking about possibly doing one of these courses maybe online. If you've got enough people gathered in one location, then we can talk about the possibility of me coming up and doing one for a group of folks. So anyway, to net it out, the way that this happens is somebody says, hey, when are you doing a class? And I say, hey, where do you live? And they go, oh, Atlanta. And then I say, all right, if we can get 8 or 10 people to come to a classroom, if you can help me find a classroom, even better. Then I'll come to Atlanta in a month, and we'll have a one-day course. So bottom line, write me at info@methodr.com, or my email ID directly is fine too, and we'll figure it out.
Perfect.
Excellent. Thank you very much, Cary.
You're welcome.
I think we've covered off the the only questions that were being asked. So again, with thanks to everybody, I think, Cary, we can let you go enjoy the rest of your day, and we'll head off into the Canadian long weekend. Family Day Monday. So.
Guys, thanks again, and I